I'm an assistant professor at West Virginia University, and welcome to this AEESP Education webinar titled Incorporating AI into the Environmental Engineering and Science Curriculum. We're really excited to have these panelists share their experiences. This is a very fast-moving thing that is going to impact all of our teaching, so I'm excited to see all of you here today. So I'll just give a quick introduction, and then we have 4 different panelists here today. Bridget Hegarty at Case Western, Andrew Katz at Virginia Tech, Kate Newhart at Oregon State, and Bu Zhao at the University of Albany, who will all share a little bit about their experiences, and then we'll have a Q&A session at the end. And at any point, if you want to put questions into the Q&A, we can answer those as we go along. So I'll start us off. We'll have short presentations from our panelists and then closing remarks and then Q&A. So just a brief introduction. We're all becoming familiar with this terminology here of data science, AI, machine learning, and deep learning. And some of us have seen more of the ChatGPT, large language model side of things. Some of us have done more of the predictions and machine learning. And these are some of the things that we have to figure out as we're teaching, and how do we integrate all this into our environmental engineering curriculum, and what are some ideas and ways that we can do so. My path into this was I had a doctoral student, Tamim Zaki, on the research side, who was looking at data science applications and resource recovery. And during his literature review, he saw that while machine learning, the manuscripts out there between 2006, 2009 were essentially zero. Even in the past 5-10 years or so, in our literature review, we saw more machine learning models than statistical models being used. So you can see this very large increasing trend in machine learning on the research side. Another way I've interacted with this a little bit is using different satellite images. We've been looking at different lagoons in the United States, and we've been able to figure out basically using data from pixels to look at different regions of the United States to be like, we know where there could be some lagoons, and being able to use satellite imagery to know what a lagoon looks like, and using different pixels and colors to be able to locate lagoons when there's not permits. So there's lots of things we can do quantitatively to come up with predictions. And there's also a lot of options to look at different images and do predictions that way. And then translating this into the classroom, this is a study from Gradura back in 2023 that said out of 40 civil and environmental engineering departments, only 7% provided training in different learning languages like Python and R, but 85% of these departments believed that the students needed those skills. So there's this disconnect here between what we're actually teaching and what we think we should teach. So I think just based on the number of people attending here today, this is something that's fast moving that we want to integrate, and now it's trying to figure out how we actually do that. There are a few different options that we can do it here, just a few ideas that I thought of. This can be something that we integrate into existing numerical methods courses, perhaps in the first couple of years of the undergraduate curriculum. Maybe this is something that we can include for like a course project or homework assignments in our existing environmental engineering courses. Maybe we encourage students to take courses outside of civil environmental engineering, or what would look like if we created our own AI machine learning course just for environmental engineering students. So I'm excited to learn from the different panelists of the different approaches they decided to take to figure out how we can give environmental engineering students these needed skills that they'll need in their work. So with that, I'm going to hand it off to Dr. Kate Newhart for her presentation.
Thank you, Kevin. I am excited to be here, and I'm going to be talking about the use of generative AI in Capstone. I would first like to thank the Capstone instructors before me here at Oregon State, Jeff Nason and Mark Carlson, as well as the OSU eCampus for some of the resources I'll be sharing today. So my integration of AI into Capstone kind of stems from the simple question of, are we preparing our students with the right skill set to succeed in their roles as engineers, given that the role is likely going to change as AI technology booms? An analogy to this is, think of 1960s NASA. Think of the human computers, right, who did the original calculations. But it wasn't until early 70s that the computers were reliable and accurate enough to actually perform the calculations sans a human in the loop, right? And so those human computers had to transition. They became the earliest programmers. They became the next data analysts and simulation specialists. And I think we're going to see a very similar transition to the role of environmental engineers. And that brings up the question, how do we teach them and what do we teach them? So a very brief AI vocabulary. Despite the title of my presentation, I will actually be focusing on GPTs, which is it's a subset, it's a very specialized large language model. And large language models can be generative AI, which is fundamentally being able to create new content. And the reason why I'm focusing on GPTs is because we see that nearly every single large consulting firm now has a pro license to a GPT product, like those in the bottom right-hand corner there. We see vendors incorporating GPT products into their softwares for better user experiences. I've seen water and wastewater utilities create custom GPTs so that they can incorporate all of their SOPs and their manuals. And so the next question is, what do we do with them in the classroom? And so this is why I think it's important for us to think of how and what we teach with this new technology of GPTs. So this brings us to Bloom's taxonomy. So here's a revisited version considering the functions that generative AI can perform. And we're used to thinking of engineering design as that highest level of Bloom's taxonomy. But does engineering design with AI still have that same criteria? We can focus in on the top part here, right? So the general trend when we segment out the functions that generative AI can perform are the basic operations: support brainstorming, identifying pros and cons, identifying trends and themes. And what this means is that now we can have our students focusing on the human side of engineering, right? One critique of Bloom's taxonomy is that it focuses too much on the cognitive domain. And with this separation, now we can really lean into the affective domain, right? We can talk about characterization and valuation. We can talk about responding and applying ideas to new contexts. So from this perspective, you can see how easy it is and how frequently, as an instructor in Capstone, I am emphasizing the human side of engineering design processes. And so with that, here are just some example learning outcomes that you could incorporate into a capstone or senior design. It could be as simple as understanding what is Gen AI and its potential applications, to actually using Gen AI to analyze and interpret data, or as a problem-solving tool itself. You could even go so far as to discuss the ethical implications of AI. We usually talk about it in terms of academic integrity, but there's a lot of other ethical considerations as you think of it in industry that could be considered. But given we have a brief amount of time today, I'm just going to talk about 3 tips that I have for implementing generative AI in the capstone. The first is to encourage and demonstrate your own use to students to give them an idea of what good usage looks like. Microsoft recommends that you have about 10 contiguous hours with a GPT product to really become proficient. The second is to use intermediate deliverables like outlines or draft assignment submissions in order to help students practice using generative AI, but also it's very easy to detect the misuse of AI with these deliverables as opposed to a giant report trying to parse through. And then finally, having what I'm going to describe as a broad but defensive acceptable use policy for AI that gives students ideas, right? And hits back with number 1, where you are encouraging the use of this product, but also has pretty strong standards to say when they've crossed the threshold of inappropriate use and the consequences of that. So starting off with number 1, you want to encourage a product, you should use the product that is licensed by your university. So for example, Oregon State University licenses Copilot. You can see here that when I log in, I have this little green check mark, which means I have enterprise level data protection. So I could upload text from a paper I'm working on or research data, and I can be sure that that will stay within the walls of OSU's IT. And it's important for students to understand this aspect as they go into their, maybe a consulting role where they might have sensitive documents, and that aspect of AI is important getting started. Next, once you've picked a product, writing a good prompt. This is not something that we're taught very explicitly, but can be a huge difference in your effectiveness with this tool. So if you wanted to say, give me a few examples of the importance of homework, right? A very, very small statement there. But if we tried to add context, as opposed to letting the GPT product infer context, you can get a much, much better product. So here we have generate 3 to 5 bullet points to prepare me a presentation on the importance of homework, focus on reliable information in the last 12 months, and use simple language so I can get to speed quickly. So providing goal, context, source, and expectations are critical to a good prompt. But it's not just prompting that we need to teach students, right? It's also conversation in these new GPT products, right? The very first chat GPT had a very short memory, so it wasn't very good at context and building that context. But the latest models are incredibly good at this. And this is an article from Anara Scott on LinkedIn. I encourage you to look it up, but she provides some examples on ways you can prompt conversations with large language models, right? So you present your challenge and then you say, ask me questions before you respond, or be very specific about the types of questions you want them, ChatGPT or Copilot or Gemini to ask you. Relevant context. Specifically ask me for the data you might think would be helpful. Or if there's a better way to word the problem, tell me that. So this might seem like small potatoes, but think about how we had to originally learn how to use Google and how searching was a key skill. Now, prompting and chatting and using this is going to be one of those fundamental skills. Next is the use of intermediate deliverables. And I'm going to use the example of a work breakdown structure, which is basically the outline of all of the tasks that will need to be researched and completed for a complete deliverable in Capstone. This assignment occurs very early in the term, so poor performance isn't necessarily detrimental to the project as a whole, but like I mentioned previously, it becomes easy to catch whether someone's actually applying critical thinking to it. So first off, obviously, provide a lecture on what the deliverable is and what your expectations are. And then you have the students submit an outline work breakdown structure or an outline deliverable that you encourage them to use this product for, right? Assuming you've already demoed an appropriate use of their GPT product. And then finally, it becomes an in-class example exercise. And I gamified this a little bit with teams, but effectively we go through an output from a GPT product and we talk about each of those points. And I demonstrate how I parse through the accuracy and the responses that the generative AI product gave me. So for example, here you can see it was a very simple prompt, right? Could have been better. Create a work breakdown structure for designing a wastewater treatment plant. And so you can see that it gives me project initiation, preliminary design, detailed design in a lot of details. Things students, having never brought this up before, would find very useful. But then it has things like construction, testing and commissioning, project closeout, operations and maintenance. So it has topics that are very generic, lacking specifics from the RFP and problem statement, and including sections that are very obviously outside the scope of Capstone. So these are really easy ways that you can see a student did not apply critical thinking. And make this the new baseline for students. Understand if you just copy and paste from ChatGPT, that's a 0. I expect you to apply more thought than that. And so my final piece I want to throw in there is, what is an acceptable use policy? Here are just some highlights from mine. I encourage outlining and drafting, obviously from the previous section, but you cannot directly quote AI, and obviously you are responsible for any sources that are either non-professional inaccurately summarized or misattributed, which is extremely common with Capstone and with sources from GPT products. I also encourage it with editing. It can be incredibly helpful. Grammarly, for example, uses AI as a backbone. But if you do use GPT products for editing, recognizing that I chose 10% kind of based on the Turnitin report thresholds that I would start to notice things happening. But ultimately, this is about students keeping their original drafts to demonstrate to me that they did come up with the original thought and that the AI was purely just used as an editing tool to improve their articulation. But as always, draw the line. Remind them that the misuse of AI tools, as outlined in these examples, is a violation of academic integrity, which sometimes students just forget, don't know. And I think once we establish these baseline proficiencies, we can start moving into the intermediate topics when we talk about bias in these models or potential copyright violation, and obviously the environmental impact. But I think without that baseline, we don't have a good place for them to grow in their knowledge and their use given these advanced topics. So the first best time to start using AI in your capstone design was obviously last year, but the second best time is right now. Thank you very much, and I look forward to your questions after the rest of the presenters.
All right, thank you so much, Kate. Our next panelist that will present is Dr. Andrew Katz from Virginia Tech.
Awesome, thanks. Let me go ahead and share my screen. Awesome. All right, thanks everyone. All right, I'm going to keep it in this view because eventually I'll probably want to switch to a few other tabs here. This is great that we get to share our own screens because there's some other resources that I don't think would have really fit in a slide deck, but I can easily switch to now. I can just hop to a few different tabs. All right. So I want to follow up on what Kate was saying. I want to talk about how I've been using generative AI in my courses. And there's lots of different ways to go about talking about this because there's lots of different use cases. One that I think is probably more interesting long-term, but not accessible, so I won't really, not immediately accessible to everyone, is using language models for cases, like case studies. So you give students open-ended cases and have them walk through those cases in a more dynamic kind of question and answer back and forth mechanisms. So a lot of the work that I do either for research or for my classes is developing these kinds of like online apps to have students walk through interacting with language models that are supposed to be simulating different cases. But what I'll actually talk about today, and I'm glad that Kate mentioned using an analogy at the beginning of her talk, I want to talk about how we've been using language models to help with conceptual understanding and explanations for students and use cases there. So we'll talk about using language models to help with student comprehension. In this case, it's talking about a data science course. So it's kind of funny seeing Kevin's slide about that small percentage of data science related courses in civil and environmental engineering, because this is going to be one of those sorts of examples. And specifically, my interest is in using figurative language and more precisely like metaphors and analogies to help with student understanding, and using those to help specifically explain students' muddiest points, so things that are still a little unclear to them. And so then the challenge that this is all trying to address is just some of these concepts in data analysis courses can be a little abstract and difficult to grasp for a number of reasons. And traditional textbook or sort of online explanations may not be the most accessible because they're either very dry or abstract or any other number of reasons. But so they just in general may not resonate with learners. So the idea is, okay, can we use language models to provide alternative perspectives or explanations? So the way this works, or the way I've been doing this in classes, is these muddiest points workflow. The idea is students submit a reflection after a data analysis, either lab or assignment, or just even after class meeting. So they identify muddiest points. Like I said, those are going to be concepts that they're still struggling with in some way. Then I, on my side, will compile all those into a shared document that's shared with like the entire class. So think of like a Google Doc or a you're a Microsoft campus, then like a document in a OneDrive, for example, and then using generative AI to generate alternative explanations, like I said, metaphors, analogies, or maybe other concrete examples. All right, so the idea is to have students, learning with AI, not replaced by it in some way. So it's a little bit more like a guide on the side approach. All the AI generated content I will review before then putting it back into that shared document. And of course, to have it always transparent about what exactly was the prompt that I was using, which language model did I use. The focus is always trying to remain on this conceptual understanding then. And hopefully along the way, kind of going to what something that Kate was mentioning earlier is to help students with developing their own skill in terms of prompting or interacting with language models. Right. So this all comes about because I found myself struggling at times to come up with examples that would resonate with students. Like I would know enough about students to kind of have a sense of what might resonate with them, but then trying to figure out on the spot what was a good way to sort of give an alternative explanation, and it wasn't really working out very well. So and we had already been working in collaborative documents for various explanations or projects or things like that. So it seemed like a natural extension to offer that here. And this is just an example of some of the different concepts. I'm sure we all teach courses where there can be some difficult concepts. So hopefully this, we don't need to linger on this list too long. But implementation wise, what does this look like? Well, so we'll start with collecting muddiest points. Now, this really comes back to an idea of from metacognition and how students will reflect on things. I just realized that I have the old slides copied in here, so there's not a convenient, nice looking figure here. I guess I can hop over to this slide deck really quickly where I pasted in our slides earlier. So this is the actual figure that I was hoping to have, which is just showing a different kind of taxonomy of metacognition. So you can kind of think about metacognition, like how do you think about thinking? And there's metacognitive knowledge and regulation. If you wanted to think about this activity using this taxonomy, what I'm really talking about doing is helping students with their metacognitive regulation and specifically monitoring. So it is these muddiest points, reflections require students to monitor their own thinking about the concepts that we're covering in class, and they will write out these assignments. So that's fine. It's usually a very simple question: what data analysis concepts remain unclear? And then they'll submit that, either via Canvas or a Google Doc that they've shared with me, and I'll compile those. All right, so let me go ahead and stay on these slides, even though they're not as, exciting because of the lack of a fun header at the top. Okay, so we use an AI-driven concept explanations, metaphors. This is coming from work, dating back to the 80s and before then about metaphors and analogies and their role in human cognition and learning specifically. So I've just put the cover to this, book, Metaphors We Live By, from the 80s, but there's a whole body of literature in the educational psychology space that focuses on metaphors, and they're always kind of fun too to see like, are there different ways to explain a certain concept. So that's where this assignment is coming from. So it's combining this idea of metacognitive regulation with muddiest points assignments and metaphors and that sort of transfer learning from analogies, right? Have these concepts and then have students submit their muddiest points, give a prompt. Now, there's lots of ways to be more elaborate with the prompts. My experience has been, especially with models more recently, that like this kind of simple enough or straightforward enough prompt will be sufficient. So I'll say, explain the concept of X. So whatever it is the student was struggling with, in this case, it was principal component analysis. So explain the concept of principal component analysis using metaphors, analogies, and simple examples that would be relevant to environmental engineering students analyzing water quality data sets. Okay. So that's step 2 in the process. Step 3 would then be creating a resource document. So then I will then take those and really you can either do this copy and pasting, or if you're in any way comfortable with programming and paying $1 to OpenAI to use their API, then you can just programmatically have a CSV file that has all of the muddiest points from a week. Just upload that, use Python, iterate through that CSV file for each row, send it with your prompt to chat GPT-4o, for example, get the response back, and then you have your put that back in your CSV, and now you just have that entire table of the muddiest points with the metaphors and analogies and so on. So that's one way to do it. Or like I said, if you're doing it just more manually, you can just copy and paste all the prompts in, and then copy those back out into your shared document. And the idea is now you have this nice running list of all these different ways for explaining different concepts. You can, have that running over the course of the semester. And by the end, now students have this nice resource that they can refer back to. And the other thing that's nice about that is you can just build on it from semester to semester if you're teaching the same courses. So this is what that might look like, a traditional explanation kind of on the left-hand side, and then an AI enhanced, version with some metaphors or alternative explanations on the right-hand side. Now, in the interest of time, I won't linger too much because I think I've already been talking for 7 or 8 minutes. But my understanding is that these slides will be shared with everyone. And also, I think I saw in the chat that the video will persist somewhere else. So I'll go ahead and just linger for a second on these slides in case someone wants to come on later and just pause it to see what's going on here. But I think everyone kind of gets the general idea of using these language models for conceptual understanding, specifically through this combination of muddiest points, reflections, plus explanations using metaphors and analogies. And here's sort of another way of framing that prompt that's a little more structured than the other example that I gave, where you have this numbered list. And then looking forward, I think that the thing that's nice about this, and the reason that I wanted to share this example is just I think it translates well to almost anything that we might be teaching. I'm pretty sure all of us will be teaching things where there are a few muddy points along the way. And so it seemed like a pretty accessible way to teach this, right? And then last thing is, and this kind of gets to one of Kate's points, just sort of iterating and working with these models can be a very helpful first step. If at first, you're not really getting great results, you might want to try tweaking your prompt or your instructions a little bit. But yeah, I think that's probably puts me at the end of my time. So I'll go ahead and hand it back to Kevin.
All right, thank you so much, Andrew. Our third panelist today is Bu Zhao from the University at Albany.
Okay, hello everyone, and thank you for having me today. And my name is Bu Zhao, and I'm an assistant professor from the University at Albany, the State University of New York. And my personal research mainly focuses on the interdisciplinary area of environmental engineering, sustainability, and also the artificial intelligence. What I try to do is to use data-driven tools such as machine learning to understand how human activities will affect the environmental systems and kind of how can we better match the spatial temporal distribution of the pollutants and their complex interaction with our systems. And today I'd like to share some of my experience and also strategies on how we can integrate AI into the environmental engineering and science curriculum. And I'm now teaching 3 courses at UAlbany, and one of them is the environment data science course. As currently, mentioned by all the panelists, the AI tools become increasingly accessible, and our role as an educator is also kind of shifting. So nowadays, the AI is actually no longer just a kind of a nice to have, but also essential skill for the future of the environmental research. So first, the complexity and also the volume of the environmental data are actually growing exponentially. So we are now all using the different types of data, such as satellite image, high-resolution climate models, and also dense kind of the data collected from the dense sensor networks. So they can generate kind of tons of data every day, and traditional tools cannot keep up with the speed of the data growth at this moment. And second, all the different AI tools can help us to enhance our ability to make prediction and response to different environment challenges, such as to the air pollution and prediction, flood forecast, for some energy system optimization. So all these AI-powered tools can enable much faster and more accurate decision-making. And the third issue is there is a clear growing demand from the industry parts. The different companies are actively seeking graduates with not only have their environmental engineering skills, but also nowadays require them to have the AI and also the data science skills. So if we want our students to be more competitive in the job market and also to make some impactful changes, so we must prepare them to work with these kind of tools. So given the growing importance of the AI, so it's time to kind of integrate the environmental data science and also the AI courses into all the different environmental science and engineering programs right now. So both for the undergraduates or the graduates program. And also it is just, as I mentioned earlier, it's no longer optional. because the students must be equipped to work with this kind of AI-powered tools and workflows. And right now, as mentioned by Kevin, the most curriculum setting is still focused on the traditional environmental science and engineering courses. So although it's now increasing, there are still very few university and program offer structured training in the data science and AI courses in the CE department or the environmental engineering department. So this actually creates a kind of a growing gap between what the students really learn and what the field really needed. So, and nowadays, more and more companies and also the job description will often include a sentence like the experience with Python, machine learning, or data analytics or preferred. So, however, the good news is actually the integration is kind of achievable right now. So we don't need to overhaul the entire programs. So even when we make a very small changes, a small module, like an introduction level to the environmental AI courses or a simple unit on the AI in climate change, like the case study, can make a big difference in the students, the future career path. So in kind of response to this needs, so in UOPNI, we have kind of made some the changes on our current curriculum setting. So I developed a courses called Environmental Data Science in the coming fall semester in our department. So this is a course designed for the senior undergraduates and also the graduates with zero foundations. This is an elective course. And this course is designed as a big picture focused because all the students previously don't have so much foundation in programming and also mathematics. So the goal is now to kind of turn the students from a single class into some statistician or the programmers, but just to help them to understand the basic logic of the different statistical tools and machine learning tools and think critically with the different data and AI tools. So this course is more question-oriented courses. So we designed this course and we'll start from some real environmental problems. And we will use data science and different statistical model to explore and kind of explain the different and solve the different problems. And also we only focus on those kind of models and tools that frequently used in the environmental engineering field without kind of diving deep into too much math or algorithms or codings. But still, the coding is still a big part of the course, but it's now the major focus. So the lab sessions are designed not just to practice coding, but designed to help the students to know the kind of the correct way to choose the proper methods and how to kind of properly interpret the results and communicate and present their findings. So we also encourage the students to use of different large language model generative AI tools like the ChatGPT or Copilot for coding. But the students are actually expected to evaluate their outputs, to verify they're providing the correct outputs and reflect on their the usage. So of course, integrating this kind of AI part into the current curriculum comes with lots of the challenges. So one common issue is that the students are currently over-rely kind of on the AI-generated contents. So I have found lots of students in my other class just copy and paste the contents generated from ChatGPT into their final reports. And students also treated the AI response as totally correct. Even I can very easily find some very clear mistakes. And based on this situation, so in my class, I told students, so it's okay for them to use ChatGPT during their writing. It's totally fine. However, they should only use it to kind of as mentioned by other panelists, to draft the outline. So I require the students to report on where is the AI generated part. So they need to mention about that to make some statement. And also they request them to cross-check and update the contents with some more scientific process. Typically there are some illusion from the large language model, and you need to update those kind of the numbers and also some statements updated with more the trustworthy sources. And another challenge is that the traditional environments like the reports or the presentations can lose some value when the students can generate some polished content directly with the AI. So to address this issue, I try to use kind of the same methods like the other panelists have mentioned, that we also do the iteration to help them to check the progress of the students. So I also break the projects into multiple stages, such as a proposal presentation, interim draft presentation, and also the final presentation. So this helps to track the progress and also avoid those kind of one-stop generation of the final results or report. And similarly, for my class previously, that is an open book exam, because a lot of it's based on the coding, but currently I found the open book exam, doing on the Brightspace or Canvas, may also lose their values, because the student can easily bypass this kind of the exam with the AI tools. So my solution is just to return back to the traditionally paper-based exams, or include some oral presentations to assess the kind of the real understanding of the students. So I think the final goal for our educator is the same. It's now to totally ban the AI tools, because that is the trend, which we have to embrace that. But to teach the students how to use it kind of critically and also transparently. So to quickly wrap up, so here are some few key takeaways from today's share. So in one sentence, I think the AI is here to stay. So all the environmental education must adapt. First, I think the important thing is it is necessary to add all this kind of data science or AI courses, which reflecting this kind of the state-of-art AI and the data science in the current environmental education programs. So even a small addition can make a very big changes on the students. And second, the students are actually already using the different AI tools. So our role is to guide them towards some more responsible and critical use. And our teaching should focus more on kind of cultivating the system thinking of the students. And the last one is the coding. It is a very powerful tool, but it's just a tool, not the final goal. So the students should learn how to choose and apply different methods, not just learn how to write the correct code. So that is kind of all the things I want to share for today. Thank you.
All right, thank you so much, Boo. Our last panelist for today is Bridget Hegarty from Case Western Reserve University.
Hi, everyone. Can you hear me?
Yes.
Okay, excellent. So one thing that Kevin mentioned was just about how we can all get started doing AI. So with my slides, I'm going to be focusing on some simple uses of AI that we can use, and to help all of us taking that first step in the classroom. And so just to introduce a little bit about me, I'm an assistant professor at Case Western Reserve University. I have my primary appointment in civil and environmental engineering, and I also have a courtesy appointment in chemical and biomolecular engineering. And currently I'm teaching 2 grad and undergrad cross-listed courses. One is a data analysis class specifically for civil and environmental engineering students, and the second is an environmental engineering biotechnology course. And my research really uses a lot of these bioinformatic tools, both in terms of the approaches that we take to understand microbiomes, but also in developing new methods. And I'm particularly thinking about phage biocontrol and healthy indoor microbiomes to be able to engineer more healthy microbiomes. And so I wanted to start off by summarizing some of the common ways that I've used AI, and these really reiterate what the previous panelists have already said. So there's 2 major ways I've done that. That's in my own work, in the research that I'm doing, and also in the classroom. And so thinking about on more the research side, I found that AI can be very useful with brainstorming and with literature searching. There's some tools out there that are getting increasingly good at helping you review the literature and support what a traditional literature review might look like using Google Scholar or Web of Science. And some of these tools are really excellent. I've also found it really useful for tuning language for different audiences. So if you have something written for a technical audience, then you can have the AI and use a conversation like some of the other panelists have mentioned to help tune it and identify what's confusing and what is not confusing. This can be particularly helpful to identify jargon that you might forget because we're so close to our own work. I've also found it increasingly useful for simple coding tasks, but I'll talk a little bit more about the pitfalls of that as I move along. And then in the classroom, I have an AI policy, and the foundation of this is that I make sure that students understand that, like with any resource, they have to acknowledge when they're using AI. And I will talk a little bit more about how making this explicit has been really useful for helping nudge students towards more useful uses of these models. I'll also talk a little bit about the challenges of using it, particularly in the context of R coding for my data analysis class, and then share an assignment that I generated for my biotechnology class that gets at some of the pitfalls of using AI. And so thinking first about that AI policy, the first time that I taught my data analysis course, ChatGPT was just becoming a thing. There was still, I had very little about AI use in my syllabus, and I also spent no time talking about it. And this led me to a position where I was only discussing AI with the students who were caught using it. And most of these students were using AI in very, very lazy ways. Kind of like some of the other presenters have said, this is when they have clearly not thought about what they're presenting, sometimes even including the prompts still in their answers. So very lazy. And this led me to the second time that I was teaching the course to have a more explicit statement in my syllabus, but also spend time on the first day to talk about the beneficial uses of AI, where I've used it in my own research in ways that are useful, but also the challenges. At this point, I also talked about some of the ethical considerations of using AI and the environmental costs. Since much of my class were environmental engineering students, I think that explicitly talking about those costs made them a little bit more hesitant to use it and think about whether this was truly like a worthwhile use. And what I found is that in this second time, the use of AI was much more sophisticated. This is partly because the tools got better over these 2 years, but students were also taking more time to acknowledge it and saying what was working well and what wasn't. And because they were using it more sophisticatedly, this led me to a better appreciation of some of the ways that it was working well for coding and ways that it wasn't. And this observation was that the AI tools were often giving much more complicated solutions than required for a problem. So students might be using Copilot or ChatGPT to understand this, and they found that they were using approaches that we hadn't got into in class and that were making things really complicated. And this made their troubleshooting harder. And it also, from a pedagogical perspective, meant that students weren't practicing using these approaches. And so something that I haven't tried yet, but I want to try the next time I teach it, is see whether requiring students to use certain functions or approaches at the start of the class when I'm trying to help establish a framework of using it would be helpful in addressing this problem of students using more complicated than necessary solutions. Another assignment that I've generated is talking about the pitfalls of AI. And the motivation behind this is that, as everyone has said so far, AI can be incredibly useful. It's not going away, but when specifically is it helpful? And this activity was very simple and was just using large language models, whether ChatGPT or Claude, to generate an abstract for a paper that they had had to read for an assignment and where they'd spend time discussing it for a journal club in class. And in the discussion, we talked a lot about in class what the LLMs did well and what they did not. And the takeaways from my students about this were that there were many similarities between the abstract that the models wrote versus what the authors had done. And one thing that students really expressed is that they had a better appreciation for how these models aren't necessarily giving you what's correct. Like they're sometimes, even with the paper in front of them, they're a language model. They don't have a conceptual understanding of these concepts. And so just to wrap up, I want to summarize some of the benefits, challenges, and questions that I see for all of this. And on the benefits side, one thing that I see is really useful is that these models can reduce a lot of the tedious work that goes into certain types of tasks. They're also making coding more accessible, and that's something that's really useful, particularly in an engineering context. And they can be incredibly useful with troubleshooting and brainstorming to help with that back and forth when you use them as they sort of are intended as like a conversation tool. However, that doesn't mean they're not without challenges, and this includes the ethical and environmental considerations of their use, and also the challenge of ensuring that students learn the basics of coding and the process of troubleshooting, particularly for my data analysis class. If they're not learning the methods of troubleshooting, then that's really missing out on a key purpose of it. And so just to leave everyone with some questions that all of us are posing and grappling with are, first, what specifically does an environmental engineer and scientist need to know how to do? What are the things that are fundamental that they need to be able to do? And what are things that maybe with the use of these models, we can offload onto that so that we can focus on more creative work, like with thinking about Bloom's taxonomy, like the first panelist. And then finally, how does this change how we educate them? And I think this panel is a great way to continue those conversations about all of this. So with that, I'd like to pass it back to Kevin.
All right, thank you so much, Bridget. All right, so just first, quick slide here. If you enjoyed this particular webinar, some of you may be attending the AEESP conference coming up in a couple weeks. During the conference, there'll be a workshop on reviving your teaching practice, and that includes the use of AI in the classroom. So if this was interesting to you, please also consider attending this workshop at the conference. So thank you all for the panelists for your presentations. If the panelists wouldn't mind turning on their videos. And then I put all the emails up here on the screen. And for those who are attending today and have any questions, you're welcome to put your questions in the Q&A box. And you're also welcome to raise your hand if you want to be unmuted and ask a question. So while we wait for those questions to come in, question for the panelists to get our conversation started. Have your efforts all been individual in nature, or have your departments started considering making formal changes to your curriculum?
I would say my department, we recently had a big conversation about academic integrity, and of course AI became a huge piece of that. So we revisited the conversation of, do we have a single uniform AI policy, right? Or do we allow each individual course to make their own? And it kind of all circled back to the same place we were at, where it is incredibly course and learning outcome dependent. And so everyone has their own individual flexibility to implement it as they see fit. However, especially with OSU's eCampus, I shared some of the resources about the Bloom's taxonomy revisitation, and they're providing a ton of resources to help support instructors incorporate AI. So I would say highly encouraged. They're putting a lot of investment into assisting instructors in incorporating it into their classwork, but no mandates or standards have been set to require it.
And to build off of that, my department, we've been having conversations about it, but what's happening is very like individual class specific. So there was interest in starting a minor in our department that specifically was about data analysis and AI. And unfortunately, the college wasn't interested in that. They don't want each individual department to have minors in this, which is understandable. But it definitely, we've started to think about that. And I hope that we begin to think more systemically so things can begin to build on each other, because right now each class is kind of doing it on its own and the prereqs aren't necessarily there so that you can assume students know certain things going into an upper level grad class.
And also from my department, we kind of as I mentioned, we propose this kind of new courses for the environmental data science, but they are still challenging because there are some existing courses courses of mathematics. So new you mention this kind of is needed, and the kind of you cannot have so many the kind of overlap with the existing courses. So you need to make your courses more and be different with those kind of existing one, and how to complement the needed for the student needs. So this is kind of our department's action.
All right. Andrew, do you have anything to add?
The only thing I would add is just probably there's something that's slightly different about my department. I forgot to mention earlier that I'm in a Department of Engineering Education at Virginia Tech. And so our department handles all of the first year engineering courses for the College of Engineering. The way that our college is organized, all the students going to any engineering discipline have to first take that like a 2-course sequence that's taught out of our department, which means that we end up spending a lot of time thinking about like what is the really sort of core set of knowledge, skills, and abilities that we're trying to help our students have, so that when they start matriculating into their disciplinary homes, then they are prepared for success. And I think that's where the AI conversation has been coming up, because electrical engineering versus civil engineering versus mechanical engineering, like those are all going to look a little different. So it's been interesting to be parts of those conversations across departments, because we'll sit in with curriculum committees with all the other departments, and there it sort of just drives home how much this looks different in different disciplines. But for us, it hasn't really meant too much movement in the curriculum yet. Just been a lot of conversation.
All right. So there are 2 questions in the Q&A that are pretty similar. They revolve around, do you ever tell students they cannot use generative AI at all? Or do you have any policies about what they can and can't use it for assignments that were traditionally done without any generative AI?
I would just like to call out that the times I've had candid conversations with students about this, it's more the confusion if within an individual class there are explicit assignments where it can and cannot be used. And so having a course-wide policy, I think, is helpful for the student if we assume best intent.
This is also part of the reason that I've had my courses have paper-based exams, because I also don't want to overly penalize students who are doing the work, because it can often be very hard to identify cheating.
So my policy would be it's impossible to totally ban the student from using this kind of ChatGPT or other generative AI tools, but we could do something to help them to there's some the zero GPT. You can check whether some of the content is kind of generated by this kind of AI. So we tell the student the policies. We could to check your output. So you need to be responsible for your the own the submissions. So students will have certain concerns. So typically you will give them this kind of warning beforehand. You need to be responsible for all your output for your the delivery.
Yeah, for me, I don't have any assignments where I specifically say you can't use it. The biggest thing has been that they need to be very transparent with anything they are doing, meaning including prompts that they used and what exactly was the output and what exactly did they do to change it. And if I have any suspicion, if I have any impressions that maybe they weren't doing all those steps, then we'll have a conversation. But to answer the question, I haven't had any specific AI, no AI permitted assignments since I guess last year.
All right. The next question is, how do any of you help students to be critical of the output of a GPT?
So that goes back to my example of the outlining the work breakdown structure. where, I'm not going to say it's a flipped classroom because I still provide them the resource of what is a work breakdown structure in a lecture beforehand, but to allow them to play around with the AI output, allow them to attempt to parse and then come back as a whole class and make it an in-class activity of parsing through that output and basically replicating the assignment. But now with giving them time to process as well as my own interpretation, which pretty standard, right? You look for the sources that it provides and how I evaluate them. I look for generalities, which is very common in, it's in a lot of redundancy. So in that same vein, and in encouraging that conversational piece as well. So saying, okay, this is the output that it gave you. Is there a better way that you could have phrased this in a prompt, or is there a better way that you could do this in conversation? And that's a bit more of an advanced usage, right? I'd say start with the type of manual assessment, and then moving forward. But that's how I have taught criticality of a GPT output, because you don't want to get it to the point where they're submitting misattribution or what could potentially be considered an academic integrity violation, because by then, the learning opportunity has been lost.
I think the other thing I would add is just that it's very similar to how we teach critical thinking about other resources, especially in my biotechnology course. We read papers and they do a final report, and we spend time talking about how do you think about the results, and beginning to build that intuition, because at first you don't necessarily have enough content or knowledge or exposure to do that, but it's building it and making sure, as Kate said, that you're checking your sources and all of that. So it's very similar to building on skills that we've already been doing.
Actually, I have very recent cases like the students using the ChatGPT to do some coding, and they provide a different answer with the standard solution and provided by my side. So I just using that case to help the students to give a bonus question to help to find out what is the difference between these kind of two solutions. One is provided by the ChatGPT and one is the standard solution provided by our textbook. And just using that case to help the students to understand, okay, sometimes the generative AI can definitely make mistakes, and I think students really take some good lessons from that kind of specific cases. So it's some private conversation, but I think this kind of conversations would be helpful.
Yeah, the other thing I'll do is I'll usually spend at least a few minutes, if not half a class, talking about how these models actually work in terms of their probabilistic nature, the idea that most of these, back to Kate's point about these, the general architectures of them, they're autoregressive language models. So, to some extent, they're just going to generate the next most likely word based on how they're sampling and so on. So I'll go into some of that stuff. It also works because, and it sounds like actually a lot of the panels also teaching data analysis classes, but it's an opportunity to talk about some aspect of data analysis, so it conveniently ties in that way. But the point is I'll try and talk about that as a way, toward helping them think more critically about how is this, language model actually functioning, and then why might that lead to some, questionable output, whether it's hallucinations or just very generic responses like other people were talking about. So that's the other way that I'll do that.
All right. Well, that ends our time today. So thank you very much for all the panelists, for your presentations and for your helpful answers, and hope everyone enjoyed this presentation, and maybe we'll see many of you at the conference in a couple weeks. So thank you very much. Have a good afternoon.